Good evening. You are welcome to another episode of our lecture. Today we are going to look at acids, bases. These are things that most of the time we know them by virtue of their action on materials. But then there are definitions for them in chemistry. So many people have proposed a definition. Arrhenius has his definition. Bronsted and Lowry do have his. And Lewis also have a definition for these chemicals. Let us look at Arrhenius. He said acids are substances that have hydrogen ion or hydrozonium ion, and they can give it out in solution. They have hydrogen ion and can give it out in solution. Such substances are referred to as acid, and substances that have OH, hydroxide or ion, are referred to as bases, while these ones are referred to as acid. That is Arrhenius' definition. But however, there are substances, of course, that do have that behave like bases or alkali, but they don't have OH. Example of such substances are the carbonates. They are basic in nature, but they don't have OH. That is the shortfall of Arrhenius' definition of acids. Then Bronsted and Lowry, what does they say? What they said is that acid is any substances that can produce proton, that is proton donor, any substance that can produce or donate proton, and a base is any substance that can accept proton. That is, acid is a proton donor, and a base is an acceptor of proton. That is what Lewis, which is more broader than what Arrhenius have said. And Professor Lewis on his own did describe acid. He did describe acid as a lone pair acceptor of electron, a lone pair acceptor of electron, that is an acid according to Professor Lewis, and a donor of the lone pair, is referred to as a base. A donor of the lone pair is referred to as a base. Now, when you talk of the lone pair, let us look at ammonia, for example. Ammonia, it has a lone pair here. When you look at the structure of ammonia, the atomic number of ammonia is 5. I think it's 5. This is 2, 1, 2, 3. And then our nitrogen is 5. Our hydrogen is 3. The hydrogen will key into this. The hydrogen will key into this, and we have our lone pair here. The atomic number of nitrogen is 7. This is 1, 2, and 5. This 5, any substance, ammonia can easily give out. It has the lone pair, hence it is a base, since it has the lone pair, and it can donate this lone pair for an acceptor of the lone pair is the acid. That is, acceptor of the lone pair is the acid. A hydrogen, a proton, can easily accept this lone pair to form ammonium compound, to form an ammonium compound. Hence, these are the 3 basic definitions of acids and bases. Arrhenius defined acid as substance that had hydrogen ion or hydrozonium ion to give, that is a giver of hydrozonium ion, and also defined a base as any substance that have OH negative group, a base. But however, we said the carbonates, like sodium carbonate, if they dissociate, they form sodium positive 2 plus carbonate 2 negative. There's no OH there, hence it doesn't really key into Arrhenius' definition of a base. But Bronsted and Lowry, he said any substance that can donate a proton is such substance acids, and an acceptor of a proton is a base. Of course, in this case, the carbonate can easily accept a proton. This is 2 negative plus 2 proton to form base, to form this HCO3. Hence, this one is the base because it can easily accept a proton, an acceptor of a proton, according to Bronsted and Lowry. And Professor Lewis, on his own, chose to define acids as an acceptor of a lone pair of electron and a base as a donor of a lone pair of electron. In our next lecture, we are going to look at properties of acids and bases, and at the same time we are going to look at the classification of acids. We have our mineral acid, we have organic acid, we list some of these examples, and we tend to know more about acids and bases, and possibly we are going to treat salt, which is a product of the reaction of an acid in a reaction known as neutralization reaction, in our next lecture. Thank you for listening to our lecture. Until we meet in our next lecture, have a beautiful day.